Okay, before we begin, I'll give you 3 minutes, and let's actually uh, download something from GitHub. I'll share the link with you. There are two files. One is a Python notebook file, and the other one is a CSV file. The CSV file contains a data set, and we are going to be using that data set pretty much for what we are going to be doing today. So I'll share the link with you, and I'll start a timer for 3 minutes. So once the timer ends, we'll begin. I hope most of you are using Google Colab. If you are using any other tools, please let me know. Or in case you need any help, also, yeah, I think you can just unmute yourself and then share whatever question you have. Okay, is anybody of you using Jupyter? Can unmute yourself. I don't think you need to be shy. Also, yeah, please upload your data set so that it can be accessed easily in Google Colab. Okay, yeah, 3 minutes are up. So, can you just raise your hand? There is a raise hand button over here. So, in case you're done, can you please click on that? Okay, just one UVCE Marvel. What about the others? Do you need more time?
Excuse me.
Yes.
Sorry, actually, there was some net issue with me. Could you repeat that? What we have to do actually right now?
Okay, as of now, you need a Python notebook and a data set, and I've uploaded both of them. I've actually created a repository in GitHub, and I've provided the link over here in the chat box. So I want you to download it as a zip, later extract it, and then we're going to be using that. So you can use it either in Jupyter Notebook or in Google Colab. I hope you got it. Is it clear? Yeah, git clone should also work. Should I give you a demonstration of how to download the file and then upload it to Colab?
Yeah, I think that would be better, Dhruva. Maybe a
Sure.
few
Okay.
beginners.
Sure. Yeah. Let me just demonstrate that as well. So this is GitHub. For people who don't know what GitHub is a project management tool. Some of us, we use it to store any code which we write. So right now I have pushed two files to GitHub. Then I'm going to be downloading it. So anybody who's has the link can download it as well. So I'll download it as a zip file. Then if I go to downloads, the zip file will be present. I can extract it, and then once I extract it, I will have the folder wherein these two files will be present. So once I do that, I will open Colab, and then I will open a new notebook. So once that's done, I will I will upload a notebook from the downloaded one. And once that's done, I will upload the dataset, which is parmerpenguins.csv. So once this is done, just let me know, okay? Just raise your hand in case that's done. If you find that difficult, it's okay as of now. We can proceed with the session. So I will give you another 1 minute and then let me know once you're done.
Can you repeat what you do after you open a new notebook?
Was I um, on mute when I said that?
Yeah, I
Yes,
believe you
yes.
were, Dhruva.
But
Okay,
then
so
I
yeah,
saw it.
yeah, okay, then that's cool. I hope you were able to understand just by making out what I was doing.
Yeah, yeah.
Yeah, I guess you can raise your hand whenever you're done, and then we'll begin. Okay, we have two hands, three hands, four, five. We have seven, eight. Anybody else who is struggling? I think we can just finish it up quickly. Okay, yeah, good number of hands. I think we can move on. So yeah, right now we are done with the downloading part. I think we will begin our session right now. So today's session is going to be on data pre-processing techniques and training techniques. There are certain techniques which may contain some inconsistencies. We need to remove them. And I would like to introduce myself. My name is Dhruva, and I'm studying in the final year of engineering in UVCE. I'm from Information Science and Engineering branch, and I'm also a software engineering intern at Fivetran. So I've started my internship, and I will be beginning the full time role in a couple of months. So yeah, let's get started with the session. So first of all, we need to know what data pre-processing is. So whenever we download some data set from the internet, they may contain noisy data or certain values in that data set may be missing, or there might be any other inconsistencies which might be there and we are not aware of it. So to solve those techniques, to solve these problems, we use something called as data pre-processing, and it is the first step which we need to follow while training a machine learning model. Also, whatever raw data we have, we need to process it and make sure it is present in a format which the machine learning model will be able to understand and use it really well. So moving on, um, there is something called as categorical data. So what is categorical data? This categorical data means that uh, if we have a certain number of values and a finite set of values, and in a column in a data set only those values keep on occurring, so this kind of data is called as categorical data. I can give you an example. Let's say we have a person and we have his nationality. The nationality depends on the nation in which he is living in, and we can determine that if we know the set of nations which are there in the world. So that is an example of categorical data. So the problem with categorical data is machine learning models will, some models will not be able to understand that. For example, random forest classifiers, They do not have any mechanism to deal with categorical data. Also, neural networks, which might be a little more advanced, they only deal with floating point variables and any other type of categorical data like strings or lists or anything. It will not be able to deal with that. So it is important for us to convert categorical data into a numerical format. So the solution for dealing with categorical data is called encoding. Encoding is nothing but replacing the categorical values with a numerical value. So let's say we have nationality of a person. So we convert that nationality into a numerical value to represent each one of them. So there are certain techniques. There are two main techniques which are used for encoding. One is called label encoding, and the other one is one-hot encoding. So label encoding, what it does is it assigns a numerical value to each categorical value. For example, let's say we have a table called island, and let's say we have a column named island, and there are four values: Torgerson, Bisco, and Torgerson and Dream. And the unique values are Torgerson, Bisco, and Dream. So what we do is we assign a value to each one of these. So for example, for Torgerson, we assign 0. For Bisco, we assign 1. For Torgerson, which we have assigned before, we again assign it as 0. And for Dream, we assign a value of 2. So this is one approach which we can use to encode categorical values. The second approach, which is called one-hot encoding approach, it is also encoding technique wherein we create a separate column for each categorical value, and we assign a true or false value to each one of them, each one of the column values. And the true or false can be represented using 0 and 1, like the way we have done here. So for Torgerson, you can set the value as 1 for the Torgerson column, and the other values remain 0. Same with Bisco, we set it as 1 and the other values are 0. Similarly, for the third row, we set it as 1 and the others are 0. And finally, we set 0 and 0 and 1 under Dream. So take around half a minute to go through this. I think you will be able to understand what it does. And yeah, if you have any questions, yeah, just let me know. Who has the Python notebook file uploaded to Colab and who can run the first cell for me? I need a volunteer, anyone? Okay, I'll go with Anjal. Anjal, can you share your screen?
No, actually, I'm using my mobile. Will it be okay with that?
Okay, mobile, I don't think it will be appropriate. Anybody else? Aryan? Okay, Aryan has raised his hand. So, Aryan, can you share your screen?
Yeah, sure. One sec. I'll just share that window.
Okay.
Mm, yeah, yeah, done. Visible?
Okay. So, I want you to run the first, you know, yeah, the first cell.
Okay. Yeah.
Okay, so this thing ran. Now I want you to remove the line which says df is equal to pandas dot get dummies. So I want you to remove that line, and I want you to replace it with print df. Can you do that for me?
Yeah.
Okay, you commented that out. It's all right.
Yeah. Yeah. Wanna run it again? Uh,
Yeah. So there is an error which occurs in the last line.
value as well.
So yeah, I want you to So this column, what's happening is there are string values over here. So this is what is called as categorical values. And also in the gender column, there are male, female values. They are also categorical values. So a model like random forest classifier will not take in categorical values, and it is expected that we should provide floating point integers into such a model. So yeah, thank you, Aryan.
Sure.
You can stop sharing.
I'll
I will
stop.
start sharing again. Yes. Okay. So yeah, getting back to this, the code which Aryan ran, just like the way he did, I commented out that one line, and we are not able to fit the data set into the model. That is because we have string values, and we are not able to convert them to float values, like Aryan mentioned. So the two techniques which I explained here, one is label encoding and the other is one-not encoding. So we'll see that over here right now. So there is a module named label encoder. There is a class named label encoder, which is present in sklearn.preprocessing. So that can be used to perform label encoding on the data frame. So we can just say df of island is equal to label encoder dot fit. Got the method. It's supposed to be fit transform. And here I provide the column which is supposed to be transformed. And same way I need to do it for the gender column as well. I will do that here. Okay. So I will have a statement which prints the data frame for me. And once I print the data frame, if we notice the values, it will have 0, 2, 3 like that. So yeah, like we saw when Aryan was presenting, Island had separate values for each one. For they had string values, and now it's converted to integers, which can also be converted to floating point values easily. Same way with gender, we have 1, 0 values, unlike before, wherein we had male and female values. So this is one way in which we convert um, categorical values into numerical values. So unlike before, where when we were getting an error, this time we were able to train a random forest classifier easily. So yeah, this is the label encoder part. And instead of label encoder, we can have the one-hot encoder. So one-hot encoder, it's pretty much one line of code. We need to use this get dummies method of the pandas module, and then it will do the label encoding for us. Sorry, it will do the one-hot encoding for us. And only thing we need to provide is the columns and the data frame. So if I print the data frame after executing this particular statement, and let's observe the data frame right now. So the data frame has a separate column for female and male genders, and it's marked as 0, 1 accordingly. Same with the island column. It has removed the island column and introduced 3 new columns, one for each categorical value, and accordingly it has set 0 and 1. So like we saw over here in the presentation, how a separate matrix is created with 0 and 1 values, the same way it is created over here. So yeah, this is how label encoding and one-hot encoding is done. So moving on, let's see some advantages and disadvantages of these two techniques of encoding. Coming to label encoding, one problem what happens is the machine learning model may treat the values as weights. So we were assigning 0, 1, 2, 3, right? So it might consider 0 as a lower weighted value, and it might consider 3 as a higher rated value. So this is one problem which happens while doing label encoding. Also, because of that problem, it might reduce the performance of the model. Coming to one-hot encoding, it has an advantage over label encoding. Since there are separate columns created for each categorical value, one-hot encoding might produce better results. But at the same time, if there are more number of categorical values, then the training time required for training a data set might be large, because the size of the data set will increase. So these are the advantages, the pros and cons of the encoding techniques. So any doubts until now? Please feel free to unmute yourself and then um, put forward your question.
Do we need to like import the something like label encoder for one hot encoding as well?
Okay, so for label encoding, there is something called as sklearn.preprocessing, and in that the label encoder class would have been written. So we need to import that for label encoder. For one-hot encoder, we just need to use pandas. We just need to import pandas, and then there is a function called get dummies within pandas. All we need to do is call that function. Nothing apart from that.
Okay, got it.
Okay. Any other doubts? Anyone? Okay. So I'm assuming nobody has doubts. So let's move on to the next concept. So the next concept which we are going to learn is imbalanced classification. So what happens is there might be data sets which have classes, and these classes, the frequency of these classes may not be equal to each other. Like for example, we took an example of nationality. So suppose we take random number of people across the world, and we have more Indians than the number of Americans or the number of Chinese individuals. So if that's the case, then the data set is said to be imbalanced because the number of Indian instances is more than the number of American or the number of Chinese instances which are there. So what happens is if we train such a model, if we train a model with such a data set, then there is a possibility of the model to make biased predictions towards the class with a greater proportion. So for example, let's say we take the height and the weight of citizens across India, America, and China, and let's say we have more number of Indian classes, and what happens is the model might predict that for every query which we make, the model might predict it as Indian more number of times compared to Chinese and American. So this is kind of undesirable because there are more number of values, and then the model is not able to predict properly. So what to do in these kind of conditions? So there are two techniques for that again over here. One is undersampling, the other one is oversampling. So in undersampling, let's say we have a class with more number of instances. That will get reduced to lower number of classes. And the number of classes will match to the lowest class which occurs. Similarly, in oversampling, we have a class which with more number of instances, and the class with less number of instances. What happens is we are creating new instances which will kind of fill the space for us. So these newly generated instances, these are random samples, and there are certain techniques which are there to generate these random samples as well. So coming to the techniques which are used for undersampling, we have two algorithms. One of them is near miss algorithm. The other one is named condensed nearest neighbor algorithm. Other than these two algorithms, there are many other algorithms, but near miss algorithm is a very popular one. Also, there are a number of algorithms for oversampling as well, and random oversampling and SMOTE, which stands for synthetic minority oversampling technique. These are two popularly used algorithms, and among these two, SMOTE is very popular. So we will take a demonstration now for this one as well. So I need a volunteer. Any volunteer who can do it for me? Other than Aryan, I want some other volunteer can run that particular cell. Okay, Sarvesh has raised his hand. Sarvesh. Okay, there is a question from UVCE MARVEL before going to Sarvesh. This is similar to the way your model starts by hearting data when you run 100 epochs over say 10 epochs, right? Kind of, yes, it's kind of similar to that. But maybe I don't know if you're speaking about oversampling or undersampling, but related regarding oversampling, maybe yes, because even in neural networks, there might be data which is being read again and again. So even in oversampling, data is generated based on its closeness to other data instances, and this keeps on repeating itself. So maybe it is similar to running epochs over and over again in neural networks. So yes. Okay, over to Sarvesh. So Sarvesh, I think you can share your screen and then execute the second and third cell for me. think second one initially, and then we will go over to the third one.
You can see, right?
Yes, yes, it's visible.
The second one.
Okay. So in the second cell which you executed, what we are doing is we are actually reading the data frame, and then we have x and y. It is actually occurring in the previous cell, the reading of the data set, and then we are using that x and y pandas data frames to generate uh, the new data frames, which consists of oversampled data and another two data sets which consist of undersampled data. And like you see, the first time the counter is displayed, we have 146 Adelie classes and 119 instances of Gen2 and 68 instances of Chinstrap. So these Adelie, Gen2 and Chinstrap are the labels which we require, or the classes which are there in this particular data set. And when we perform oversampling, we notice that we have more number of Gen 2 instances and more number of Chinstrap instances. And the number of instances of both Gen 2 and Chinstrap are equal to the number of Adelie instances. So clearly, the algorithm, which is smart, it has generated new samples for Gen 2 and Chinstrap to match the number of Adelie samples. So this, it kind of makes the data set equal, and it will provide us better training. So what would have happened before? We might have got more Adelie predictions from the particular model, but after we increase the number of samples of the other two, we might get a fair prediction based on the query which we give. And also in the third line, if you see in the output, the number of instances of Adelie has been reduced from 146 to 68. Same with Gen 2, it has been reduced from 119 to 68. And Chinstrap, which was the lowest, which had the minimum number of instances, it remains the same, it is 68. And all the three instances has a frequency of 68. So this is an example of undersampling. Okay, so moving on to the next cell. Can you run the next cell for me, Sarvesh? So this cell, what it is doing is it is plotting the graph between the bill length and the bill depth for each instance, and according to the classes which each instance belongs to, it is marked in the graph as using colors as red, lime, or black. So the first graph which we can observe, the scatter graph, we can observe the real clusters, and in the next graph, which is clusters of oversampling graphs, we can observe that we can observe the instances after the oversampling has been performed, and in the third graph, we can observe the clusters after undersampling has been performed. So Sarvesh, if you can zoom out a little and then kind of display all the three together, is that possible? A little more, yes. Okay, cool. So I want all of you to take some time and then observe the graphs. You will observe that the number of instances is more and less when you compare the graph, the bottom two graphs with the above one. So take some time and then can somebody point out to what might have changed in those graphs? Take probably 1 minute and then we will discuss regarding this. Okay, so were any of you able to find out any differences between the graphs? What could have changed, etc.? Sarvesh, do you notice any changes?
Um, in oversampling, the green and the black one, like there are more number of like cases, and undersampling there is like less to match the 68 and the 146 thing.
Correct, correct. What about oversampling? What do you notice when you compare it with the real clusters?
And the green one is more.
Yes,
It is as equal to the red one because it
correct,
is the
correct,
highest one.
correct. So also the black one stands for think the third. Which one was it? Gen 2, I guess. Yes, Gen 2. So the black one, which stands for Gen 2, there are more number of samples in the clusters oversampling, but because the number is close to 159, I think the change is not very much apparent when we look at it using the naked eye. But in the undersampling graph, we can clearly see that there are data points which form a cluster in the bottom part of the graph, and the ones which are close to the green points, those points have been eliminated when we perform undersampling. Same with the green points as well. The ones which are close to red points have been eliminated. But there are certain points which have still been retained. Since we are comparing only two columns, maybe we are not able to see for which other columns those values might have been separated. So, yes, any doubts so far related to imbalanced classification and oversampling and undersampling? Thank you, Sarvesh. You can stop sharing. Okay, any doubts so far related to oversampling and undersampling or imbalanced classification?
The from collection, when you import for imbalance classification, like the from collections import counter and all,
Mhm.
is that from like pandas or is there?
No, there is a certain library called collections. So this library is actually used to deal with categorical data, not categorical data exactly, but let's say you have some number of lists, and then you want to kind of make collections out of it. So it's used there, and it's not particularly used in machine learning. It has wide range of applications in areas other than machine learning as well. So when you compare it with libraries like NumPy and Pandas, which are which find more number of applications in machine learning compared to other domains, this one I can say it is pretty generic. It is generally used in other domains as well.
Okay.
Okay, cool. So moving on. Uh, yeah, does anybody else have any other doubts?
I had a simple doubt.
Okay,
So
sure.
we learned that there are two types of undersampling and oversampling respectively. So
Yeah.
among those two, did we choose the more efficient one while running the code, or did we use both? Did we implement both right now?
So what we did was we implemented both of them. And if you observe in the notebook, we are not performing any training. So I will that I wanted to explain it after the demonstration.
Okay.
So the thing is, these techniques are suitable for data sets with a large number of instances. So the data set which we are using, the Palmer Penguins data set, it is a really small data set. It contains of only 300 and something, more than 300 values. So these techniques are much more suitable for data sets which contains something like 2 crores or more than 2 crores number of instances. So you will really notice the change when you try to train your model over those data sets. If I had actually performed, if I had actually tried to fit this data set after performing the undersampling, and then let's say if I had used a random forest classifier and trained that data set, so what would have happened is I would have got less accuracy. That's because the number of samples are really low in this data set. So
Okay.
yeah, that limitation is there. So yeah, please keep it in mind so that I think you might have been wondering why the implementation was not done for this particular concept. So yeah, like I explained it before, we would have got less accuracy because the data set is small. So in general, we use these techniques on really large data sets.
Got it. Thank you.
Okay. So one more thing before proceeding, related to undersampling and oversampling. So these two techniques are used in their own ways. So there might be applications wherein performing undersampling might give us a better accuracy, and performing oversampling might give us a better accuracy. So we need to be, mindful of the fact that these two techniques are independent of each other, and they might provide better performance based on the data set. And we need to use these techniques accordingly, according to the data set which we have. So yeah, that was it related to undersampling and oversampling. So let's move on. So moving on, let's know something about something called as feature engineering. So feature engineering, it mostly deals with transformation of data sets, and these transformation, it is done to actually increase the accuracy of the machine learning models. So the transformation is mostly altering the data which is present. So, for example, in image processing, we perform feature engineering to extract certain features which consists of a particular animal, and we want to extract the features of the animal, and maybe we need not worry about the background whatever is there. So in applications like these, we will use feature engineering. So today we will be learning about one particular technique which comes under the category of feature engineering. This technique, it is called as scaling. So what scaling does is it transforms the data to make it fit into a particular scale. So let's say the range of the data, the numerical value in a column, let's say it lies between 100 to minus 100. So we want to change the range of that to probably increase the performance of a machine learning model, or we may want to increase of the speed in which we train the machine learning model. So to do that, we use scaling, and so the 100 and minus 100 range which we have, we can reduce it to 1 and minus 1. So I'll give you an example, okay? So let's say we have a column. Let's say the column has, height of a person, and it contains the values 90, 80, and probably 40. So this we can convert it into compressed form. Like we can make it fit into a range between 1 and 0. Sorry, it'll be the other way around, between 0 and 1. So right now the range is between 0 and 100. Let's say if there are more number of values, the range will lie between 0 and 100. So this we can convert it to maybe 9 can become 0.9, and 80 can become 0.8, and 40 can become 0.4. So you see the values after performing the scaling, it comes down to this range compared to these values which fit into this particular range. So you see the difference, right? So this is called scaling, and it might increase the accuracy of our model along with better training times. And let's take a look at the demonstration as well. So yeah, again, I need a volunteer. Any volunteer can do that for me. So again, we are not, doing the implementation. We are not training any model for the scaling as well. That's because the data set which we are using, the Palmer Penguin data set, is small. So maybe if we had a bigger data set, we could have really noticed the change. But for Palmer Penguin data set, we won't notice the change when we do the scaling and then train a machine learning model. The accuracy just won't improve because it's small. So yeah, any volunteers other than Sarvesh and Aryan? I want another volunteer, a third volunteer. Anybody who wants to volunteer? Prashank, can you volunteer for us?
Actually faced a problem while uploading the
Data set?
the penguin data set. Yeah.
Okay. Somebody else? Matthew, can you volunteer for us?
Yeah, okay, I can try. But
Okay, sure.
yeah, I'll try.
Okay. No problem. We have 19 other participants, so anybody can volunteer if Matthew is not able to do it properly.
The problem with this is most of my that code was not running. It was showing some errors and it was not showing for the rest of them.
Yeah,
Okay.
same thing happened with me. That's why I was trying not to.
Okay. So any other volunteer? Can Sahar volunteer for us?
It's Seher, and like I had the same trouble as Matthew and Rishang, so yeah.
Oh, okay. Hey, yeah, I
Can you
think
just
we can.
demonstrate once how to upload the Excel sheet?
Yeah, I think I will demonstrate it later. So we'll just
Sure.
wrap this up. Okay. Sujay wants to volunteer. Yeah, over to you, Sujay. Okay, can you run the cell under feature scaling? I hope you have run the previous cells as well. Okay, you have run it. Okay, so what we are doing is the x value, the x variable which is there, it contains the data frame from the previous cells which we ran. So the x which we see here, it contains numerical data between some hundreds or some thousands or some tens or something. And once we perform the scaling using standard scaler, we notice that it has converted into a NumPy array, and it has a lower range compared to the previous ones. So, Sujay, if you can move up and then show the previous data frame which was there. So, okay, you just need to put a print df statement somewhere. I think in the first cell. After the dropping, can you just put a dropping of nan values? Can you put print df statement and then just run it again? Okay, yeah. So if you notice here, especially the bill length, the bill depth, and the flipper length, the values are really big. It is in the range of tens and hundreds, and the body mass is in a range of thousands. So the same thing if you go down to the last cell. So the output of the last cell, it actually contains values in a much lower range. The range has reduced. It is, in ones, and there are decimal values as well. So this is the change which we can notice after performing scaling. So this, if we fit it into a machine learning model, we will be getting much better accuracy. But yeah, since the data set is small, the Parmer data set is small, we won't be getting an increase in the accuracy if we perform scaling and then train our model. So in case you come across any other bigger data sets wherein these techniques might be needed to get a better accuracy, I think you can use these techniques and you will get better performance from the models. So yeah, thank you, Sujay. The technique which we have used here, it is called a standard scaler. Apart from these two, there is another technique called min-max scaling. So standard scaling, what it does is it actually converts values within a range of 0 and 1, and the range might increase to maybe 0 and 2 or 0 and 3. Whereas the min-max scaler, it tries to converge the values into a range between -1 and 1. So you can read about this in a lot of other places as well. Also, the underlying algorithm which is being used, that will also be explained to you in when you refer to documentations of these as well. So I would encourage you to try and read about these techniques, the implementation under these techniques. I think you will be in a better position to understand them. So yeah, any questions? I think we have come to the end of our session. So I will be taking any questions from you if you have any of them. Okay, there is a question from UVCE MARVEL. Training a model to give movie recommendation based on ratings, where a lot of the values are nan and there are big ranges. I think this would be helpful. Okay, there is one thing which I forgot to mention. There are methods for replacing nan values as well. So one thing which can be done is nan values can be eliminated itself from the data set. So rows which contain nan values, they will be removed. So if anybody would have observed here, I'm doing that for the Palmer Penguin dataset. I'm dropping values. I'm dropping rows which contain nan values. So there are disadvantages of this technique also. You might be losing a significant amount of data, and so yes, like you have mentioned here in the chat, we can replace those values with the average of the remaining values, or sometimes median and mean. These values are also used to replace. So which one is a better idea in general? Okay, depends on the data set which you are using. If the data set contains a lot of nan values, and you notice that if you remove the nan values, then there is no imbalance among the classes in the data set, then it's okay to remove values. But If there is a loss of balance in the data set, then I think you can go ahead with the replacement with the average value or the mean value. You can even use median and mean as well. And yeah, the mean replacement with the mean value is usually preferred. So yeah, any other questions? Yeah, two of you had questions. You had errors. I think you can share your screen and then we'll try to resolve those errors right now.
I actually just got it, so it's okay.
Okay, okay. Good to know
Yeah,
that.
even I just got it just now.
Oh yeah, same.
Yeah,
Okay,
we
so
didn't upload the Palmer Penguin Excel.
oh, okay,
So,
okay,
Yeah,
okay.
same issue.
Yeah, I think I forgot to mention, and then later I realized. So I think I mentioned somewhere in between. So maybe it would have got mixed with while I was explaining other stuff as well. Okay, even Sujay Vikram was struggling with the same. Okay, so one more thing that I want to explain. Okay, this I encountered while I was trying to upload a really huge data set into Google Colab. This data set, it was of 2 GB memory. It consumed 2 GB, and I was trying to upload it to Google Colab. So what happened at that time was um, maybe because while uploading there were some errors, the values were not proper. So in that time, what you have to do is you have to probably upload it to Google Drive and then later access your data set from Google Drive and then read and write data. So when I tried that, I was able to successfully read those values, and yes, from there on the training went smooth. So yeah, apart from that, any other questions? Anyone? Is this being recorded? Can UVCE Marvel just confirm? I had to ask this in the beginning, but forgot. Okay, I generally stick to 100K and less. Okay. Okay, you generally stick to 100K. Okay, I think, yeah, if you want to reduce the size of your data set, I think you can, use undersampling, and then probably if there are imbalanced classes, I think two needs will be satisfied in the same time. One is reducing the data set, and the other one is solving the problem of imbalanced classes. Sometimes you might have to increase the number of instances also because there might be insufficient number of samples. In that time, you can go for oversampling. Um, Also, yeah, oversampling has its disadvantages as well. You might end up generating a lot of new instances, and there will be the amount of time that needs to be that will be consumed while training your model. It might increase, so that's one disadvantage it's there with oversampling. Which different is recognition? How different is recognition from generation algorithm wise? I'm not sure which recognition you're referring to. Also, I don't think I have come across this. So I actually have a friend who knows this, and probably he will be in a better position to explain this. Um, but in general, can you specify what your any kind of particular kind of recognition which you are referring to here in the question? Okay, image processing and recognition versus image generation from natural language. Okay. Yeah, like I mentioned before, I don't think I have enough expertise with this. So, yeah, maybe if I try exploring this and then if I'm able to implement something successful, then I think I will be in a better position to, share some knowledge regarding this. But as of now, yeah, I have to agree that I don't have much expertise into this, especially with the generation part. So yeah, can any one of you share your experience or any difficulties which you faced while trying to train a model, and what you did to solve that model, if solve that problem? If possible, can you share it now? So Matthew, yeah, can you volunteer for us and then like try to explain any of your experience with training machine learning models and some difficulties which you faced?
I have zero experience in that.
Okay. Oh, okay. So, yeah, what about small data sets? Have you tried like Iris data set or anything?
No.
Okay, I think yeah. After this session, I think you can give it a try. Aryan, what about you? Have you like tried anything and you faced any problems while doing so?
Well, my experience was during importing a data from a text file. I had empty spaces, and that was not easy to convert it into a CSV file. Then I used use column something, and I got the necessary columns. That's it, and discarded the empty columns. That
Okay,
was one issue I faced recently.
okay. So, just curious. So, this data set, did you take it from some random place or did you try
Yes,
generating
yes.
it?
Actually, it was a data set from my dad's office. He
Okay,
wanted it for some processing to from for some plotting activity.
okay,
It was a bit random, so yeah, it wasn't very structured way.
okay. So, was it in a CSV format or in any
No, no, it
different
was in
format?
a text format,
Okay,
text file
okay,
format.
okay.
I had to convert it into its no, CSV file. So
And what library did you mention that you used for
pandas,
that? Pandas, okay,
pandas. Yes.
okay. So, any other experiences, Sahar?
No, that was
Can you share any
Yeah,
experiences?
I'm a beginner too. I have no experience yet.
Okay, okay, cool, no worries. I think you can try after
Yeah,
this.
yeah, I'll give it a try. Yeah.
Prashank, what about you? You're in second year. I know you personally, so
Yeah.
any
So that's
experience?
what I just started getting into it a few days back. So I'm just getting interested in all of this.
Okay,
I'm
cool.
giving a little more focus on DS and the fundamentals. So I'll just
Mhm.
dive into this soon enough.
Okay, cool, cool. What about Sujay? You've been in Marvel for a long time, so maybe I'm assuming that you would have tried something. Okay, beginners still. So anybody from the senior batch who has tried anything? Can you share your experience? What about juniors? So okay,
I
Sarvesh, yeah, go ahead.
so I dealt with I tried on a Kaggle this data set
Mm-hmm.
of the Titanic thing, and then when you divide the data into input and output,
Mm-hmm.
there's output needs to be in a 1D, one dimension, and then input needs to be in two dimension or something like that.
Yes, yes,
So that was this thing where you can use iLock data frame.
yes, yes.
That is
Yes, yes.
something that I would like to share.
Okay. Okay, UVC Marvel has mentioned something. Adrian and his friends are trying a wet waste dataset train split method, right? Sorry, wet waste dataset. So, what does wet waste dataset do? Can you tell more about it? Can you tell more about the project, in fact? So, yeah, while UVC Marvel is typing, so I'll get back to Sarvesh. So, one thing that I noticed with the Titanic dataset was there were a lot of missing values and there were a lot of null values, if I'm correct. Did you
Yes,
notice that?
yes.
Yeah, so yeah, that was one problem which I faced, and I had to replace those null values and missing values with the average of the other values. And there were a lot of redundant columns within the data set, and those redundant columns I needed to drop. Like there was a column which contained the seat number or something, or the cabin in which they are traveling, something like that. I've
Yes.
forgotten. So yeah, I thought that those columns may not be required, so and I had to drop those. Also, yeah, it is a competition. The Titanic dataset problem. It is a competition in Kaggle, and I would encourage all of you to give it a try. And then I'm sure you will, have to implement these techniques which you just learned today to train models for the Titanic dataset problem. So yeah, UVC Marvel, can you please explain more about the wet waste dataset and then the problem which you're trying to solve? Product, okay, project called Y Waste, and that. GUI for recognition, okay. Recognition for is it to recognize waste materials based on certain properties? Okay, now you're not entirely sure. No problem. So interesting project which you're working at Marvel. So I'm assuming probably you are trying to recognize waste materials, okay, based on whether they're biodegradable or non-biodegradable. I'm assuming that you're using certain characteristics of the waste materials like the texture or the weight or something like that. Or maybe you might be using images also. Um, Not completely aware. Okay, you're using image recognition. Okay, that's cool. I think the problem that you're trying to solve, it has a lot of significance, and it is a common problem because waste separation. Um, to perform waste separation, instead of having humans, if you probably have machines or something, maybe you can perform it much quickly and much more efficiently. So yeah, I think what you're doing might be applicable over there. So it's a really cool project. Okay, so I have a project which I worked on. I've been working on this way back from 2020. So during the COVID-19 pandemic, got this idea. So what we are doing in this project is we are trying to train a machine learning model, and the machine learning what it does is it tries to estimate the severity of a COVID-19 patient and probably try to predict whether that person is susceptible of dying from COVID-19 or not. So for this, we are using both classification as well as regression. So the classification model will make predictions as to whether the person will die or not, and the machine learning and the regression model, it will try to assign a severity score for a particular patient. So in this, I had to use a really large data set. The size of the data set is 2 GB, and it took a lot of time for me to just upload the data set, as well as I had to train it, and then Google Colab wouldn't allow me to train my data set because it wouldn't allow me to train my model because there was a lot of RAM being consumed. So I had to perform undersampling and then remove instances which are not necessary, and also had to remove instances which were repetitive. So by repetitive, I mean it had a closely relative values, and these values, they were pretty much neighbors to each other. The values were very close to each other. So instead of having multiple values with close proximity, I had to have one value with which represents the other values, something like an average of the remaining values. So this kind of brought down the size of the data set from 2 GB to around half a GB. And after doing that, I was able to train my model much efficiently. So yeah, some of the techniques which we discussed today, I'm using those techniques here. So some basics which I did was had to replace new existing values with new values. So I had to convert numerical values into true or false values. Also, you know had to I think I removed null values for this because the null values were repetitive, and it was kind of like an overburden to the data set. And also I think I have used undersampling for this. Yes, so I have used undersampling, and I have done that using the near miss algorithm. So yeah, the undersampling which I did on this data set, it played a major role in reducing the size of the data set. Initially, after performing the pre-processing and all, it kind of got reduced to 1.5 GB, I think. And from the 1.5 GB, it reduced to 0.5 GB. So what was happening was there were a lot of values, which had in those values the patient was not dying. The patient was like really healthy, and he was able to recover successfully from COVID-19. Whereas the values for which the patient was dying because of COVID-19, that was really low. So what I did was, for the values for which the patient was not dying, I had to bring it down and match it with the size of the patients who were dying from COVID-19. So yeah, after that I was able to train my model pretty easily. So the over consumption of RAM, that wasn't happening after that. So yeah, a really cool project which I worked on, and yeah, I thought of sharing that with you. Okay. Yeah, thank you. I think, yeah, documentation, yeah, it was pretty much necessary because I had to present this particular project in a number of hackathons and in some webinars as well. So for that, I had to work on the documentation. So yeah, I've been working on it for a pretty long time from 2020. Actually, I worked on it in fragments, like I wasn't working on it continuously. So in each time frame, I did some improvements each time I was working on it. So yeah, um, pretty cool project. One of my pet projects. Okay, 2.25 years in the making. Yes, yes, exactly. A lot of time I spent on it. I think a lot of machine learning projects in the industry, they are constantly evolving, and once they deploy it, they are trying to find improvements in that, and they keep on trying to improvise it um, as much as possible as time passes. So yeah, and also they try to recruit a lot of new talent. So yeah, it's a constantly evolving field. A lot of what to say? There is a lot of demand for the field. So yeah, any feedback on the session? I think I have a bad throat, so I wasn't able to explain really well. So apart from that, any feedback from all of you? Yeah, I'm really open to feedback. Okay, even if it's negative, yeah, please feel free to share what you felt about the session. Workshop was good. We'll have a proper series, perhaps. Okay, yeah. Maybe on the weekends I will be available, so probably yes. Think we can, have a couple of sessions and then record them as well. Yeah, and create a series out of all the sessions are that we make. Okay. Yeah. Any feedback? Sarvesh, Prashank, Sahar, Akanksh, Matthew, Sujay. I would really like to take your feedback. Others were there in the session. Puneet, Mohak Tiwari, Grishma, Diksha, Christina, Shreya, Viksha. Anybody of you, if you have any feedback, yeah, please let me know. Was pretty well tabulated and classified. Okay, thank you very much. Anything else? Note feedback. Good session though. Sort of needed to catch up. Okay, cool. Good to know that. Loved the way it was presented. Looking forward to more workshops. Okay, cool. Thank you, Sujay. Thank you everyone for attending. Hope it helped and really looking forward to catching up with you guys in upcoming sessions as well. So probably if you have anything to share with anybody else, probably I think you can go ahead, take the initiative and conduct sessions. I think even if your seniors don't know something, I think you should come forward and then conduct sessions and then probably educate your seniors. Probably I will learn something if I don't know anything from you guys. So yeah. Okay, think we can wind up. So anybody from Marvel team can, thank you, Shreya. So yeah, Marvel team volunteers. Anybody there? Anybody who can help me to wind it up?
Um, what exactly what do you mean by winding up?
Uh, is there any like procedure like you stop recording, anything like that?
I'll stop recording.
Okay, so we stop recording and then leave one by one. Cool.
Sure. The batch 3 students who are here, we'll be having an orientation offline for you guys on Monday. So do attend, okay? It's compulsory. You don't have an option to not.
By the way, how are the batches divided? Like batch one is the senior batch, or batch two is this? Batch three is the senior most batch.
So batch one is the oldest batch. When Marvel started, the first batch that came was batch one.
Okay.
Batch two happened. It began 6 months ago,
Okay.
and batch three just started. As
Okay.
in their
Cool.
orientations on Monday.
Oh, okay. Orientation at college, is it? In
Yeah,
person?
in person.
Okay.
So a lot of these people, Matthew, Seher, and Aryan, Puneet, a lot of
Mm-hmm.
them are all batch three students.
Okay. Mm-hmm.
So basically, this is their first foray into data science, I think.
Okay. Okay. Oh, yeah. Forgot to mention. So you're worked on the machine learning and the implementation part, and I think you don't have much exposure to data science part. If I'm wrong, let me know. Okay.
Yeah, that's kind of true. This time for the syllabus, I was planning to implement a lot more data science,
Okay. Okay.
at least like a couple of tasks more every level. We have three levels in the syllabus.
Mm-hmm. Okay.
So
Cool.
yeah.
Cool. Yeah, I wanted
Okay
to
then.
ask you something else. Forgot about it. Yeah, so regarding the projects, like what happened in the past, you prescribed them any projects or they got to work on what they are comfortable with? Like they pick up a problem and then try to solve it using machine learning. Did they do that or no, it was just the implementation which was prescribed?
So we generally for the syllabus itself we prescribe implementation, but
Okay.
for let's say there's some hackathon or something, then
Mhm.
we just encourage people to join and they pick their own ideas.
Okay, okay. Cool, cool.
Yeah, right now most
Okay,
projects that are happening, they're just self-picking and doing.
okay, okay. Yeah, that's cool. I think self-picking and doing is kind of comfortable for the participants. I would really prefer that. Also, regarding the hackathons which they are attending, can you like name a few of them? And probably, I am curious to know what kind of problem statements have come up over there.
I'll send this list to you.
Okay, okay, sure, sure. In
Yeah.
general, are these hackathons wherein they are given a problem statement and they can come up with any approach, or are these competitions wherein they are given a data set and they need to train a machine learning model uh, to make predictions over that data set? Is it that? Is it the first one or the second one?
See, this I'm not sure about others. Personally, I can answer. That's all. I'll have to inquire with the others.
Okay, yeah, no problem. I think personally, what have you tried?
I've so most of the contests I've attended are just Kaggle ones, so where
Okay,
data sets are already given.
okay.
Yeah, I want to participate in a hackathon where the kind of problem statement given and thing stuff like that.
Yeah,
That seems much more of a, I don't know, detailed approach. You have to put in a lot more thought.
yeah. I think yeah. One thing which I noticed while participating in such competitions is that the ones which are similar to the contests conducted in Kaggle, so they might help you to build your knowledge upon all these techniques like pre-processing, feature extraction, all of that. Whereas the hackathons, which take place wherein you are given a real world problem and you need to try and come up with a solution. So these ones are pretty generic, and you can, come up with a wide range of approaches. But in these hackathons, I don't think you will be able to learn about pre processing techniques and feature extraction techniques, all of these. So, yeah, there are pros and cons. There are, trade-offs between both of them. Yeah, but nevertheless, given the opportunities, just feel free to participate. Make time for that. Think you'll
Yeah.
be getting a lot when you participate in such competitions and hackathons.
The very first introduction per se that I had to data science was through. So I was just randomly browsing YouTube and I came across this video on advanced regression.
Okay.
And at that point, I'd not done regression at all, so I didn't have much clue.
Okay.
So half of that just went over my head. But I came back to that video after learning a little bit, and then all of this uh, pandas, train test split and stuff, all of that made a lot more sense.
Okay.
Dealing with nan values and etc.
Okay. Yeah.
So yeah, that was yeah. You're right about the huge amount of knowledge increase.
Correct. Okay. Yeah. Yeah. One more question which I had. Okay. It's regarding to today's session. So, did anybody of you feel that things went over your head, like you weren't able to understand anything at all? Did that happen to any one of you? Yeah, feel free to tell it. There's no problem with telling that. Or in case you did not understand anything, also any particular thing, you can just let me know.
I had a very vague idea of what was happening. I just wish I had more knowledge diving into this, but I still got a general overview of what was happening. I wasn't completely clueless because I
Okay.
went through the prerequisites since yesterday. I should have done more. It was released 3 days back, but I just
Okay.
went through the prerequisites yesterday and today, the entire day. So that sort of helped me understand what was happening. I read about pandas and that helped me a little bit, but I just wish I had more knowledge coming into the workshop.
Okay. Yeah, I think study material for these it's pretty much available in a lot of places. So there is no shortage of resources to build your knowledge upon these concepts. There are advanced concepts also. I think you should know about them. And these advanced concepts, most of them, it is used in particular domains. Like, for example, in image processing, there are certain techniques which are used, and there are certain techniques in natural processing, natural language processing, which are used, and you can't use them interchangeably. So these techniques also exist, but the ones which you kind of which were conducted today in the session. So these concepts, I think they're pretty much generic and can be used everywhere. Yeah, okay. I think I've trained a model and tried building a GUI, but the GUI doesn't work. So, okay, just curious to know how does the GUI, how is the GUI making use of predictions made by the model? Okay, I'm assuming Grishma is there in UVC Marvel. I think you can explain it in words.
So basically, what the project is I'm going to pass this off for Kagad as something entirely different, but for now, what it is basically it maps out images and converts them to avatars.
Okay.
It's just like a fun pet project thing,
Oh,
and
mhm.
yeah, so I trained the model on like 30K images. I found this on
Okay.
Kaggle.
Okay.
And now what's happening is the I'm not able to access video feed. I can give it a video feed from saved on system, but somehow camera isn't working.
Oh, okay. Oh, I'm not aware of that as well. So I have a little less expertise in this. So yeah, maybe I'll try to learn about this when time permits.
Yeah, I'm using Tkinter and OpenCV for camera
Okay.
parts.
Okay. Okay. Yeah, I'll try it. It sounded interesting, so I think I'll try it.
Yeah,
Also,
definitely.
is Marvel conducting any competition? I think you should conduct, Kaggle-like competition on a regular basis. There are many data sets available, and probably you can pick one each time and then split it into two sets, one for training and one for testing. And then you have the classes of the testing data set hidden, and maybe when the participant trains their model on the training data set and then makes predictions using the testing data set, so those predictions can be compared with the the classes in the testing data set, and then a score can be evaluated. So I think Marvel can conduct that on a regular basis. Think about it. What
Yeah,
do you
that's
think?
a good idea. I wanted to implement something like encode, but for data science or yeah,
Exactly, exactly. Yes.
it would be very fun also.
I mean, was this idea there in your minds before, or was somebody, did somebody propose the same thing in the
So
past?
for the batch 3, I just wanted to revamp the old syllabus because someone told me it's boring.
Oh, okay, okay.
So yeah, that's when I thought maybe having a few contests and stuff would mix it up a little bit, and they'd have a lot more of the competitive spirit.
Okay. Yeah, that's true. That's true. Competition, like, it will keep you hungry for knowledge, hungry for performance, all of that. So yeah, I think you'll be able to learn quicker. So yeah, try implementing that, and if it goes well, probably you can increase the frequency, something like that.
Yeah.
Mhm. You aren't conducting any event for the upcoming fest. Something is coming up, right? I guess impetus or something.
Yeah, Impetus is coming up, and we'll be having a stall there.
Okay,
Right now, it's just a few fun games, but we wanted to display a couple of projects also.
okay, okay. Yeah, cool. You can go with that.
One of those would hopefully be this one, where the GUI itself is not working.
Oh, okay. Yeah, I think you can present whatever has been done so far, and then
Yeah,
you can just explain that you are going to do these things in the future.
yeah,
Yeah, okay. So it's late right now, 8:45. I think we had a good session for 1 hour 45 minutes. So we'll wind it up here. Thank you guys. Thank you everyone. So hope this session was helpful to you, and really looking forward to seeing you work on these and then probably implement these in your projects as well. Okay. See you. Bye bye.
thanks a lot for this session. We learned a lot.
Oh, okay. Cool. Good to know that. Thank you. Bye bye.